Alrighty, hello everyone. Welcome back to another YouTube video showcasing some of the SANS Holiday Hack Challenge. This has been a ton of fun so far. We're looking at KringleCon 4 2021 edition. In the last video, we just wrapped up the shellcode primer or objective number 6. And now in this video, we're going to see what's next. I don't know, because we're going through this cold. I don't know what I'm up against. I'm just kind of playing along and learning as we go. So let's check out our badge and see what our next task is for printer exploitation. It says investigate the stolen Kringle Castle printer. Get shell access to the read contents of var spool printer log. What is the name of the last file printed with an XLS X extension? Find Ruby sister? Okay, in Jack's office for help with this objective. How the heck do I get into Jack's office though? I still didn't figure that out. I feel like I have to bump around and learn. Can I get into Jack's office now? Was there a way to get to it when I was climbing all those steps? I don't really want to hear. Yep, it still beeps and yells at me. So, okay, let's do our, I guess, jumping around. But no, this just brings us to the gift shop. Spend money. I know it. I know we need to spend money. If I go to the rooftop, though, does it tell me anything up here? Let me momentarily check the Discord. Maybe, like, am I going out of order or something for something? Let me open up Discord. Okay, so I'm over here in the Discord. I'm in the shellcode primer chat because I wanted to not spoil anything for the next challenge, but no one is asking about this. So I guess I'll just kind of search for Jack's office. No, that doesn't help. Office? No. How do I get to Jack's office? Oh, goodness, I'm looking at Objective 10. I didn't really want to do that. Take me back, and then I will run around and figure out what I'm completely missing here, like an idiot. So let me hop back over and just explore a little bit more. Okay, after pausing the video, I found it like immediately just by like walking from the rooftop of the Frost Tower back into the kind of staging area of the stairs, way over on the left as you saw me walk through. Apparently this is it. There is a restroom here, allegedly. Hi, noxious odor. And Jack's office has a gold toilet, a golden sink, but it doesn't have a bidet. So I don't think he's really that fancy. You got to have a bidet if you have a gold toilet, you know? And here's Ruby's sister. Oh, and there's the shellcode primer activity and some documents seemingly on the table. I don't know, but let's talk to Ruby and see what she's got going on. What's up? Hey, I'm Ruby. Don't listen to anything about my sister and Greta. Don't listen to what she says about me. I'm looking at the system, and it has me a little bit worried. If I didn't know better, I'd say someone here is learning how to hack North Pole systems. Who's got that kind of nerve? Anyway, I hear some elf on the other roof knows a thing about this type of thing. Oh man, what is this all about? Great work, though. What? So first things first, you should definitely take a look at the firmware. With that in hand, you should pick it apart and see what's there. Do you know what did I do this task already or something? Did you know that if you append multiple files in the type, something else is processed? Have you heard of the hash extension attack? If something isn't working, be sure to check the output. The error messages are very verbose. Everything else accomplished, you might just be able to get that shell access to the dusty old thing. Okay. Did I do something already? Like how did I get those hints? I don't think I solved the previous challenge. Did I? Whatever. Anyway, let's get to Objective 7 for printer exploitation. Looks like we're looking at printer firmware. When analyzing a device, it's always a good idea to pick apart the firmware. Sometimes these things come down base 64 encoded. Hash extension attacks can be super handy super handy when there's some type of validation to be circumvented. And then dropping files. Files placed in applib public incoming will be accessible under this link, printer.kringlecastle.com incoming. So the objectives, did that offer a link for the printer? Yes, it did. Printer.kringlecastle.com. All right, so let's see what we're up against here. I'm opening this up. This is the link for the hash extension attack. Skull security. Is this Ron Bowes? I'm pretty sure this is. If I go back to it, can I go to his homepage? Does it explain? Does it tell me? Oh yeah. Ron Bowes, other great, fantastic, incredible champion in cybersecurity. Super duper smart. I'm jealous. He's a wizard with binary code. Everything you need to know about hash length extension attacks. Let's look at this after we explore our printer. Okay, so we have the printer clause, given the local address that we're accessing it at, or the web address, contact name, Chris Kringle, location North Pole. We have device status, but we don't have much ink. Cartridge very low. Can I get more details? Oh, nope. Something breaks. Looks like a Ruby application. Route not found, get supply status. I'm going to take me out of full screen so I can see the URL here. Let's go back to the status page. And did that make a request? It didn't change the URL. Let me open up the network tab in developer tools and just zoom in on that to see if it actually made a request. Yeah. I hit, it tried to go to supply status, but that failed. Okay. I'm assuming that's added in an iframe, but it didn't change my URL. This must be viewing its own iframe and modifying things. So if I refresh the page, yeah. You can see printer.kringlecastle.com, and this printer status one is what's returned. But I'm assuming, okay, this is just the raw HTML that's being displayed here. So that's that. Good enough. Tells us the device type, tells us more information, approximately up. Okay. Can I find the firmware? Ooh, I'm going to bring this window down yet again because it wasn't showing me some of the stuff that I wanted to see. General settings takes me to login, and we need to know passwords. I'm going to try password, but login is disabled, so that doesn't work for us. How about bookmarks, printer settings? That all needs a specific login that I can't get to. All of this seemingly needs /login. Super annoying. Okay, so I can't modify those settings without any of that access. The reports that we might be able to access here, we can get to config, statistics, and information and event log are all behind the login page. Same with the print server setup page, but settings we might be able to get to. Oh, no, it took me just to settings. Not helpful. What about the firmware update? Ooh, there it is. Firmware must be updated as assigned firmware blob. Firmware choose file, no file chosen. Oh, so I'd have to supply stuff, and I could update it, but I want to download the current firmware. It looks like it's JSON. Weird. Let's open a terminal. And do I already have a Holiday Hack Challenge directory? No. All right, so let's go ahead and make one. And let's move that downloads. What was that file called? Firmware. Let's bring it into this directory, and let's go ahead and open this up in Sublime Text. So I have a text editor to look at here. Oh, it is going to be in long JSON format that isn't formatted. So let me use a plugin for Pretty JSON or some extension in Sublime Text to be able to format this nice and easy. Okay, but all this firmware is actually just base64 encoded. So that's the only entries here. Let's go ahead and actually save this as a separate file. I'll call it firmware.b64. And I'll hop back to the terminal and actually use base64 to decode that. And if folks are listening and don't exactly know, hey, John, I'm kind of new to this. How did you detect that that was base64? The random capitalization and set of numbers, and especially at the very, very end, you can see the two equal signs. That actually is a fine indicator that this is base64, because You might gain an eye for it. You might be able to start to identify this more and more. The more you get exposed to it, the more familiar you are with it. But the random set of numbers, occasional plus sign or forward slashes for binary data that you might see encoded, I don't know. It's something that you get a little bit of a trained eye for. But the equal signs at the very, very end, that's padding that's used in base 64. So you'll oftentimes see that. I base 64 decoded this, but I want to redirect it to like a firmware file, I suppose. And then let's kind of identify what that thing is. Firmware file. And it looks like a zip archive. Okay, so we could actually move and change that file extension. We'll call it firmware.zip. And let's actually, before I start to unzip this, let's make a directory for that. So let's move the firmware zip file, I guess it's still called file, into that firmware directory. I realize this is incredibly confusing with the names, sorry. But now let's go ahead and move that to have a zip extension so I can very easily just unzip it. Perfect. Now we have firmware.bin, which is a binary, which is a file, which is actually an executable that we could play with. Can I just simply run strings on that? Get an idea for what this thing is. It's a Linux executable that explains with a couple strings in here for basic super Dumbo simple reconnaissance. Firmware is up to date. It's a main function. And that's all that it seems to do, or at least that's all that it seems to contain in code. Completed.7325. I'm going to try and run ltrace and actually execute this. And that's all that it does. We already ran strings. Does strace do anything? It's literally all it does. It just writes firmware's up to date to the file. Okay. Am I just supposed to compile and create my own then? Is that the gist here? It seems like it. So what is the goal? what am I supposed to do here? Investigate the stolen Kringle Castle printer. Get shell access to read the contents, and our hints were down below. We knew that it was base 64 encoded. We need a hash extension attack. And we have to validate some kind of thing. I'm assuming that's going to be the SHA-256 thing. Files placed in applib public incoming will be placed in this location. So I'll go to /incoming. And it didn't actually have anything there. But it told me that it would. Am I going to the wrong location? No. I don't think so. Okay. Whatever. Let's read about this hash extension attack, and let's see if we can figure out and make more sense of what the heck I'm supposed to do. I'm going to assume that the signature is kind of what we'll have to determine. And the secret length is something that we might be able to take advantage of by performing this hash extension attack. And the algorithm tells us and clues us in as to how we generated this hash. So we need to create our own firmware, right? I'm going to assume copy and paste it into a given incoming location. And it would execute and run. But we need to be able to do this validation here. If I were to just modify this to be whatever I wanted to, would I be able to do that? Let me try that. And I will try and automate this process. So let's do like a we'll make our own. So let's do a stupid script.python file. And I'm going to get super duper wacky in here. I'm going to actually make a Python script, compile and run or compile C code. So that way I can, you know, work with this a little bit better. Let's open up subprocess or import that as a module. And let's say C source can equal this right here. And I'll use and include C standard IO. Is that how it's represented? Or is it just standard IO.h? Or even any of this? I don't know. We're going to find out. Let's do an int main and let's do a puts hello world with a semicolon and then see if we could actually use this. Let's do a, probably actually write some of this. Let's go ahead and import OS or shutil or other things that we might just need to copy and move files. So let's open a temporary file and let's actually get one of those. Let's get a temp file. Python temp file, please. Temporary file mode, write, buffering, etc., etc., etc. Returns a file-like object that I can write to. Okay, cool. So let's just use t equals temp file dot temporary file t dot write C source. Does that need to be bytes? Probably. And will it return a name for me, or how can I actually retrieve the name? Name temporary file. How do I get the name? Does it tell me? Maybe the Python temp file get name temporary file. How about that? Oh, tf.name. Is there a way to do that? It just like access that? It does it? So how about named temporary file? Can I do a t.close and print out, let's use a format string super quick there. T.name? Does that work? Yeah, it does. Okay, awesome. So we've put that on the file system, allegedly. Did it just die as soon as I like removed it? I should have probably verified. Yeah, it puts it in a random thing. Maybe it removes it right after it's done running. So let me add a input line here so I can then run the script, and then let's ls and temp to see if that temporary file exists. Or is it because I closed it that it might not be there anymore? Let's try it now. There it is. Okay, cool. So it'll exist for the context of me closing it or not. Will I still be able to read from it or like pass open that file object? I would hope so. We wrote to it. So let's try to use like a, maybe I can get a, so let's use a source file. Oh, sorry. I wanted to write the C source. And then let's also use a compiled binary. And we probably want to call that like, we probably want to call that a specific thing. Let's call it just temp firmware.bin, because I'm assuming it's going to need the same file name. So we could potentially, let's do awful things. And let's use OS system so that we could use GCC on that. We again make this even worse. Let's use an F string for our source file .name and then compile that out to compiled binary. Yeah? How about that? Now we won't print this out anymore, but we'll try it. And that errored. So what's the error? T is not defined? Oh yeah, because you don't exist anymore. You're a source file. How about that? That doesn't like how I have things set up. Int main exists. Did it not? Or did I not write it the way that I should have? Let's try and use the input to see this happen again. Yeah, it should have actually created that down below, but I can see it doesn't have any contents present. So can I do a flush? Is that how it works? Let's try that. Nope, that doesn't do it. Is that a thing? Maybe I'm making this too hard. Maybe I'm making this more work for myself where I really don't need to be. Is there a way that I could just compile like a binary blob within Python on the fly? I'm not sure. So, but it's right after I close the file, but I still want to be able to get the contents in there. So Python write to temp file and use it, maybe? Ah. Plus T. If you want to write data to the temp file, you can use the write lines. That... Does that not work? Does that work? I'm going to assume that it lets us do that. So let's try it. So when we open it, mode should equal W plus T. Yeah? How about that? Now write needs a string rather than bytes this time. Okay, we slap that in. But it still doesn't actually like save it. Maybe it needs the right lines still. And let's do the source file seek. Let's actually print out to verify that we've read it. Let's try that. Seek expected an argument. Oh, yep, probably needs a 0 in there to go to move the cursor of the file to the very front. Okay, so it read it, and now it's writing it. That works. And GCC needs to be done probably just following. Right? File format not recognized. Oh, I don't care, man. I can pass it a suffix, right? Let's call it a .c. And let's see if that works. Let's go ahead and print out our source file .name and verify that it ran. Cool. Now we're actually compiling it on the fly. It does need a proper include, though. So there we go. Why do you not know what that is? You should know what that is. Okay. It doesn't need the C prefix. But now I should ideally have a firmware.bin file. Hello? Oh, that's in temp. I need to actually preface it with a /, please. Good enough. So now I've got the binary cruising. If I actually wanted to run it, it should tell me hello world. Nice and easy. And now I want to add this to a zip file. And then base64 encode the zip file. So Python add to zip file. Can I just do this all in memory? How about in memory? Yeah, cool. So super simple, super easy, bytes IO in memory, good enough. That page is not loading. We'll grab it from Stack Overflow. However, this syntax looks just fine. Like, let's steal that. Oh, come on. Now the page loads. Okay, so here's a fine example. Let's try it. Do I need to move into this directory to be specifically using the name temp? I don't want to write it. Let's try that. Let's do a change directory to /temp for the moment. And let's clean up this code, by the way. Do we need this seek? Let's try that. Let's try and remove our temp firmware.bin and see if it actually recreates itself. Oh, come on. Try it. Nope. It does need the seek. Makes sense. There our firmware.bin comes in. So now that we've changed directory into temp, we could go ahead and zip some stuff up. We will need zip file, and we will need bytes IO to be able to do this stuff in memory. Yeah. So now we could actually just define an in-memory byte string, kind of as it showcases here. We can make a zip file. Yeah, ZF is probably a better word to use because zip file is going to get super confusing. We'll use in memory, and then mode, I'm going to assume, have to be write. And then if you want to add a file, we need to do some specific things. Zip file. How about just add to a zip file, please? Right. Path to file. And and then the name. Is that how I do it? Yeah. Oh, it does it with the with statement, which is much nicer. With this as ZF, we will use ZF.write given our compiled binary, apparently with a destination name. So it'll just add the file, right? Yeah. Let's just call it firmware.bin then. Or like an OS path base name. That's probably better to do. That way we just get the base file name or firmware.bin rather than the full path with temp. We'll call it compile binary. Great. So now if I go ahead and print out the ZF data, can I seek to that actually? I'll probably have to seek backwards. Ooh. And that will all need to be within the context manager. But let's see. Oh, it doesn't like my tabs and spaces? You suck. How about that? Zip file has no attribute seek. Are you kidding me? How did you do this earlier? How did you do that in the previous page? You literally did it. And that page is going to take forever to load again. Can I just get zip file data? Or no. It has to be like in memory, right? Is that what it is? Let's see that. There we go. And then we want to run get data. Is that how it's done? Get underscore data. Data. How do I retrieve the data out of a bytes.io object? I just want the bytes, man. Get value. Oh my goodness. Now you got this. Hey, now we have a... Nice. Now we allegedly have a zip file? I think. Yeah, we do. There's a PK header. It looks like a zip file to me. So let's base64 encode that. Import base64. So we can base64.b64 encode the zip file in memory, and now we could say, okay, b64 can actually equal that. Can I print out that b64 even outside of the context manager? Well, let me do that. Oh, I forgot a parentheses there. Cool. Now we got base 64 of our compiled binary inside of a zip file, and we could add this eventually to a JSON thing. So let's import JSON. And we need to mask this thing, right? So slap all of this in, and we want to be able to replace some of this. Yeah, actually, I think that's totally fine. But we do need to be able to get the correct signature. So the firmware should actually equal our own B64. We'll call that new JSON data. But we need to do this, I'm assuming, hash extension attack, or whatever. Let's just try and write this thing. Let's just do a JSON dot dumps, or can I dump to a file? Given jump will read in an object, will it not? On its own? Some quick Googling. What? Show me the dump. Object, file pointer. Yeah, so it will need something to write. So we don't even need to change directory anymore because we're giving it to the path, and we can just use it in the same current directory. So we'll say format dump for our object, new JSON data, and then we'll use a new firmware, we'll call it new firmware export.json. And theoretically, I could view, we don't need the sub terminal anymore. Theoretically, we could run this script and yeah, you need to actually make that file. Sorry. Do a WB, please. There we go. And we no longer need to print that out anymore because I trust the fact that we've generated that base 64. Let's try that. What is the problem now? A bytes-like object is required? Oh god, we have to encode it. When we... Does it need to be... Excuse me? So, JSON dump. Oh, our new JSON data needs to be serialize an object to a formatted string using this conversion table. Let me scroll through this just a bit. What if I just make it right then on its own? Object of type bytes is not JSON serialized. Hello? What are you talking about? Oh, the base 64, because that is bytes, that needs to be decoded? That makes sense. There we go. So I think I accidentally just created it. Let me show you. I needed to make sure that the data was still being represented as bytes. But now when we cat this out, here we have our JSON script. Let's JQ this to make that visible. There. Excuse me. Now we have our JSON file. So could I try and upload this? Will it let me do that despite having the bad file hash, or will it be able to recognize it? Let's go into HHC for our made new firmware. Let's try and update this. Failed to verify the signature. So that is what we do need to break with the hash length extension attack. What we can do then is, without even knowing the secret, because the printer knows that, we could try and get something that might still match. Or how could I track that down? Let's go read that, everything we need to know about hash length extension attacks. An application is susceptible to a hash-length extension attack if it prepends, as we see it doing, a secret value to a string, hashes it with a vulnerable algorithm. I don't know if it's strictly vulnerable, but I mean, I guess for this, and entrusts the attacker with both the string and the hash, but not the secret. Then the server relies on the secret to decide whether or not the data returned later is the same as the original data. So we knew the original raw data from the current secret from the current firmware, and it says even if the attacker doesn't know the length of the prepended secret or the value of the prepended secret, it can still generate a valid hash for secret data attacker controlled data. Oh, can we give it multiple files? Is that the gimmick? That's what I think it was mentioning. Or who told me about that? Who said you could just add multiple files? Was that Ruby? If you append multiple files of that type, the last one is processed. Ooh. Gotcha. So we would have to add the original one in there too. Is that just because it's base 64? Or does it need like a whole separate body? Like a JSON key set up? I don't know. Let's say original firmware can equal this. And maybe we just tack it on. But anyway, before we dive into that, let's figure out what we're doing with this hash-length extension attack. This is done by simply picking up where the hashing algorithm left off. Turns out 100% of the state needed to continue a hash is in the output of most hashing algorithms. We simply load that state into the appropriate hash structure and continue hashing. Given a hash that is composed of a string with an unknown prefix, an attacker can append to the string and produce a new hash that still has the unknown prefix. Let's look at a step-by-step example. Let's say we have a secret, which we don't know. We have data, the original data, and our hash is MD5 in this example. Signature equals hash of secret data appending on our data. The server sends data and signature to the attacker. Correct. The attacker guesses that H is MD5 simply by its length. We know that it's SHA-256, though. Knowing only data, H, and signature, the attacker's goal is to append appending data and generate a valid signature for this new data. And this is easy to do. Before we look at the actual attack, we have to talk a little bit about padding. When calculating the hash, the secret or the string is padded with 1s and 0s, followed by the length of the string. That is, in hex, the padding is hex 80 byte. Why is it strictly that? Followed by some number of 0 bytes, and then the length. The number of hex 0 bytes and the number of bytes reserved for the length and the way the length is encoded depends on the particular algorithm and block size. Okay. With most algorithms in SHA-256, the string is padded until its length is congruent to 56 bytes or mod 64. To put it another way, its length is padded until the length is 8 bytes less than a full 64-byte block. The 8 bytes being the size of the encoded length field. There are two hashes implemented in the hash extender that don't use these values. Oh, hash extender? A hash extender looks like a tool we'll be using, I'm assuming. SHA-512 doesn't matter. Whirlpool doesn't matter. That's fine. In our example, length of secret over data is 10 bytes. So, or 80 bits. Because you multiply it by 8. So we have 10 bytes of data, 46 bytes of padding, and an 8-byte little endian field, a length field. Dear God. This is getting very confusing to read out loud. Okay. I'm just gonna hit the I believe button on that, knowing the math that needs to be done. The hash of that block is what we ultimately want to calculate and get the server to calculate. The value of that block of data can be calculated in two different ways: by sticking in a buffer and performing hbuffer, by starting at the end of the first block using the state we already know from signature and hashing a pen start from that state. The first method is what the server will do, and the second is what the attacker will do. Let's look at the server first, since it's the easier example. I got to admit, do you just give me a tool that kind of just does this? Yeah, hash extender tool. Sounds about right. I will press the I believe button for the moment and then just harness my inner script kiddie. Because it's 5 in the morning, and we can continue for the time being. This explains it the same way as the blog post, but I want to know about the usage of this tool, please. Okay, data, the original data, secret, length, and then append the data that we want to append and the original signature. So we could figure this out super duper easy then. Let's do it. We can just use this. It doesn't have any releases? No, I just need to compile and make this. Okay, so let's grab hash extender. Super quick. Let's git clone this. Yeah. Make. Great. Now I have hash extender. And there are things that I need to be able to supply. Let me grab this previous syntax that I saw down at the bottom as the example, and let's just fill in the blanks for what we know given all of this. So data should be our original firmware data. Does this read from a file, or is it just passed in? Nope, it's all just passed in. So this is going to be disgusting. Slap that there. And down below, the secret length we knew is 16. Modify that. And our script should return our new base64 data, right? So let's go ahead and print that out. B64. And I'll just do that within Sublime Text. So now all of this data is what we'd like to add. And we need the original signature, which we have in the original JSON file. Paste that in, and the format is now SHA-256. So this is going to be an extremely long command, but let's try it. Pasting that all in, we got something. Got a lot of A's, seemingly your hex value. Is it supposed to output this in hex? Oh, you can pass it as a file. I'm dumb. Output option as a table. Looks like it does it in hex. Can I have it display as raw? Looks like out data format. Or let's do the table. Out data format equals raw. So this is going to be the base64 that we need. Let me bring this to a new file. Let's bring this to hash extender output. And now let's go ahead and subble what that might be. Hello? Oh, output, please. Thank you. Okay, so we have a new signature. and our new string, which is that base64 rendition there. So let's take this original thing and we'll call it our new one. And let's slap in the base64 that we have as the giant firmware. Was that originally what it started with? A UES? It is. Okay, so it looks like we have the first data set correct, and then our new one added in. And our new signature has to be updated. So, honestly, this should be what we need in our new firmware update, and pass that there. Good. So we aren't doing anything with our code yet, but let's just see if this will actually allow it to upload. Let's use this new firmware with the underscore, hit update, and that's still not quite right. Okay. I'm going to take a breather and probably pause here because it is 5 in the morning, and I'd still like to play with this and make sense of it, but I'm not quite getting it right just yet. Oh, I included the wrong thing there. Before I go, let's verify that one more time. Let's choose this file again. Update. And it's still not getting it. Odd. But I will review this in a bit. I think we've got a lot of good work done here, though. And we've set ourselves up to be able to automate this if we need to make rapid changes to our actual firmware and source code. But let's pause and call it a day, because I've been going at this for a while and I should sleep. So thanks so much for watching, everybody. If you managed to stick through this, we'll continue in the next video, I guess. Bye.